Okay, so let's get started and let's dive into our next unit, which is about the basics of the atom, and then later we'll get into the nuclear chemistry. But first, we just want to start off here with the basics of the atom, and I thought a good place to start would be with this question. Consider a neutral atom of O18, whatever neutral means and whatever O18 means, and then we want to figure out the mass of the particles which make up this atom. Okay, so where do we start? Well, let's start here with the atom. And let's ask ourselves what makes up the atom. So let's come over here. Let's say particles that are in the atom. And when I say particles, I want to focus on three major particles. Now, there are other particles which are subprotonic or subneutronic, quarks and things like that, but that's beyond our scope. So let's just focus on the basic particles. And the three that we want to focus on are the electron, the proton, and the, way over here, neutron. Good. So these are the three particles which make up the atom, and we want to ask ourselves a question about their mass, their charge, and their location in the atom. So let's start with the mass. What is the mass of an electron? The mass of an electron is 5.486 times 10 to the minus fourth AMU. Now, what's an AMU? An AMU, atomic mass unit, is an arbitrary number based on carbon-12, and that's what we'll use, and you'll see in a minute why that is. The mass of a proton is 1.0073 AMU, and the mass of a neutron is 1.0087 AMU. And if you look at my mass of my neutron and proton to 2 sig figs, you see why we like the AMU. Because when you look at only 2 sig figs, then we'd say that the mass of the proton is 1.0 and the mass of the neutron is only 1.0 AMUs. Now, for this class, we need to know the whole thing. 1.0073 AMUs is the mass of the proton, and 1.0087 AMUs is the mass of the neutron. Good. Charge. So that's mass. Charge. What's the charge of an electron? We're going to go with the assumed charge versus the real charge. The assumed charge is a minus 1. Good. What's the charge on the proton? Plus 1. And what's the charge on the neutron? There is no charge on the neutron. 0. And then finally, a location. What's the location of the electron? Well, it can really be anywhere outside the nucleus. And we'll get into nucleus. We'll get into, that's nice. We'll get into the location of the electron in much greater detail in the next chapter. But for the time being, let's just learn that it is outside of the nucleus. Where's the proton? Well, that means the proton is inside the nucleus. And where's the neutron? Also inside the nucleus. Good. Well, do we know enough to answer our first question? Let's see. Well, we know something about the mass now, don't we? We say that an electron is 5.486 times 10 to the minus fourth AMUs. We say that the neutron is 1.0087 AMU, and that the proton is 1.0073 AMU. If only we knew something about neutral and O18. Okay, so I think we need some more notes here. So let's pop on back. Let's see if we can get some more notes here. Okay, so I'm going to take this and we're going to extend it down here so that we have more space. And let's change color. Good. So now let's talk about representation. representing or representation of an atom. And one way we can represent an atom is using something like this and a number. We've got an X and a number. What's the X stand for? The X stands for the symbol of the element. So the elements symbol. And what's the number stand for? The number stands for something that we call the mass number. Okay, now what is a mass number? Well, the mass number is equal to the number of neutrons plus the number of protons. Good. So if we have something like O18, what does that mean? Well, that means that is oxygen, and that it has a total number of particles in the nucleus of 18. So that would mean that that is equal to the number of protons plus the number of neutrons. Now, can I figure out either of these things from this? Well, what do we know about oxygen? If we look at oxygen on the periodic table, we'll see in the upper right-hand corner that there is an 8 there. Now that 8 is what we call the atomic number. How do I spell atomic? Atomic number. And the atomic number is equal to the number of protons in an atom. Good. So when I look on the periodic table, see, here's the periodic table. There's an O here, and there's an 8 up there, and that is my atomic number. Good. So if I know my atomic number, I know the number of protons, then that means I can figure out the number of neutrons, because 18 equals the number of protons, 8, plus the number of neutrons. Neutrons, in this case, equal 10. Good. So you can understand how this representation can help us find out some things. Great. So let's go back to our question here. And now I know that I have, based on this, I have 8 protons. And I said 18 is equal to my 8 protons plus n. And so n we said is equal to 10. So now I know that I have 10 neutrons, 8 protons. But how do I figure out the number of electrons? Well, the key here is neutral. Neutral means what? Neutral means neutral. Neutral means I have the same number of negatives as positives. Negatives as positive. What is negative in my atom? Well, electrons. What are positive? What is positive in my atom? Well, protons. So if it's neutral, that means I have the same number of protons as electrons. So anything that's neutral, when I have a neutral atom, the number of protons equals the number of electrons. This is neutral. Yoink. So what does that mean? I have 8 protons. That means I have 8 electrons. Finally, I think we can answer our question. We want to know the mass, right? We want to know the mass, so I'm going to take 8 times protons, 8 protons times 1.0073 AMU, plus 10 neutrons, 10 times 1.0087 AMU, plus 8 times 5.486 times 10 to the minus 4th AMU. And what's that equal? I need to grab my handy dandy calculator, and let's see. 8 times 1.0073 plus 10 times 1.0087 plus 8 times 5.486 times 10 to the minus 4th, and my answer is 18.1497888. Of course, I can only be significant to the 4th decimal, blah, 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 right there. So what is my totally correct answer? 18.149. Have to round this 7. And what I'm going to do, I'm going to round it up. AMU. There we go. That's how we do it. Let's see if you can do it. You have a neutral atom of carbon-14. What is the mass of the particles comprising this atom? So let's take some time and work on that. Okay, let's see what we can do here. Let's start up here with carbon-14. Carbon, if we look at carbon on the periodic table, we'll see carbon, and up in the upper right-hand corner, we'll see a 6, and that 6 we know is the atomic number. That means that there are 6 protons in carbon. This is carbon. 14, what's the 14? That's my mass number, which is equal to the number of protons plus the number of neutrons. My mass number is 14. The number of protons is 6. So I can figure out my neutrons. N is equal to 8. So I have 6 protons, 8 neutrons. We say it's neutral. What does neutral mean? Neutral means that I have a neutral charge, which means that the number of protons equals the number of electrons. If I have 6 protons here, that means I must have 6 electrons. Okay, now we can do our math. I have 6 protons. Each proton has a mass of 1.0073 AMU. I have 6 electrons. Each electron has a mass of 5.486 times 10 to the minus 4th AMU. And I have, what did I say, 8 neutrons times a mass of 1.0087 AMU. When I add these dogs together, what do I get? 6 times 1.0073 plus 6 times 5.486 times 10 to the minus 4th plus 8 times 1.0087. If my calculator works, I have 14.11669. I can only be significant to the 1, 2, 3, 4th decimal, 1, 2, 3, 4th decimal. I have to round that 9, and my answer is 14.1167 AMU. We did it. Okay, let's see how we do. Later. Ciao, Bella.